Okay, had several people ask to create a video for factoring of special cases and factor by grouping. Special cases covers two different types of factoring. The one is the difference of perfect squares. Perfect squares. And the other one is the perfect trinomial square. What I'm noticing from just observing in class is students do not know their squares. 1 is a perfect square because it is 1 times 1. 4 is 2 times 2. 9 is 3 times 3. By definition of a square, it's anything times itself. So any number times itself that gives you a perfect square. 16, 4 times 4. So all of these are perfect squares. 25 is 5 times 5. 36 is 6 times 6. 49, 7 times 7. 64 is 8 times 8. So again, these numbers are perfect squares. Let's go a little bit higher. Let's do 81, which is 9 times 9, and 100, which is 10 times 10. You should actually be able to recognize up to at least 15. 11 times 11, and then 144 is 12 times 12. So again, what I have boxed here are perfect squares. The difference of perfect squares comes from a binomial. So a binomial can only be the difference of perfect squares. Okay. And if it's not, then you can't factor it. Either it is or it isn't. So if I give you x squared minus 10, it's a binomial. X squared is a perfect square. Any variable that has an even numbered exponent is a perfect square. 10 is not a perfect square. There is nothing times itself that will give you 10. I know a lot of you are probably thinking 5 times 5. Well, 5 times 5 gives you 25, not 10. So if I were to factor this, this is a perfect square, this is not, you're done. That would be your final answer. But if I change it to have x squared minus 16, x squared has an even exponent. 16 is 4 times 4, and it is the difference. So that means it will factor into two binomials. Take your x squared, gives you x and x. 16 is 4 and 4, and it has to be a plus and a minus. That is a 4, by the way. Oh my goodness, I just made it worse. So x plus 4, x minus 4. The reason why you have a plus and a minus is because if you are doing FOIL, first, outers, inners, lasts, your outers would give you a negative 4x, and your inners would give you a positive 4x, and they would cancel each other out. So you're actually just doing the F and the L. Okay, so let's do 4x to the 8th minus 16. This one's kind of a trick because 4 is the greatest common factor, and it's also perfect square. So you should get in the habit of taking out your GCFs first. So that leaves me 8 to the x minus 4. This is the difference of perfect squares. It's going to break down into two binomials, x to the 4th minus 2 and x to the 4th plus 2. Do not forget to bring down your greatest common factor. Once you have a binomial, you have to check to see, is it possibly the difference of perfect squares? Again, can I simplify it or break it down even more? X to the fourth is a perfect square. It is the difference, but 2 is not a perfect square. Some of you are probably thinking 1 times 1, but that gives you 1. So this is my answer. A perfect trinomial square is mainly a shortcut. I'm not a big fan of teaching the shortcut, but if I don't, then you're going to get some really big numbers, or could get some really big numbers. So a perfect trinomial square. Okay, first of all, we're right back to a trinomial again. Let's give you 4x squared. I'm going to cheat here a minute, so give me a second. Okay, so 4x squared plus 20x plus 25. If I were to do product sum, it would still work, but I'm getting a fairly large number here. So if I would get a big number for the product, I would probably check to see if it is a perfect trinomial square. You have 3 questions to ask. Is the first term a perfect square? 4x squared. So this breaks down to 2x and 2x. So yes, it is. The second one is the last term a perfect square? So 25 gives you 5 times 5. This last term must be positive. If it's not positive, don't even check to see if it is the difference of perfect square, or excuse me, if it is a perfect trinomial square or not. The third one is a little bit confusing. The question is, does one factor from the first term times one factor from the last term times 2 equal the middle term? If you say no to any one of these questions, it's automatically not a perfect trinomial square. So that gives me a perfect square. This is a perfect square. So does 2x, one factor from the first term, times one factor from my last term, times 2, give me my middle term? And I get a 10 and I get a 20x. So yes, it does. If you have a perfect trinomial square, it breaks down to 2 binomials that are the same. Take your equal factors of 2x and a 5. So 2x and 2x, 5 and 5. Whatever sign this is, that's what those have to be. So I could write this as 2x plus 5, that quantity squared. Do not get this confused with the difference of perfect squares where you have one as a positive and one as a negative, because I need that middle term. Last one is the factor by grouping. Basically what we're looking at is 4 terms. So what you are doing is, I'm going to kind of cheat here a minute. Just ignore me for a minute. I'm going to, give me a second. I thought I had my paper in front of me and I don't. Okay, maybe kind of a challenging one. If we have 3m squared minus 5m squared p plus 3p squared minus 5p to the third. Okay, now this is one that we have not seen before. 4 terms. The first thing I'm going to do is I'm going to group the first two and the last two. If for some reason I group the first two and there's no GCF, and I group the last two and there's also no GCF, what you need to do is just simply take these two middle terms and just switch them. Okay, so I'm going to group the first two and the last two. These have m's in common, so I'm going to take out an m squared, which leaves me 3 minus 5p. I'm going to take out a positive p squared, which leaves me a 3 minus 5p again. Remember, these binomials have to be identical. They are, so that is my GCF. And the garbage left gives me m squared plus p squared. You have to check to make sure that one of these is not the difference of perfect squares again, and that you would need to actually factor it out even more. I'm going to try to find one more that would be a good more than one method problem. Let's do 75n to the third minus 27n. 75 is not a perfect square. It's a binomial, so the only thing it can be is the difference of perfect squares. I always got to check for greatest common factor first. 3 goes in here, and so does n. So that leaves 25n squared minus 9. So I took out a GCF. Now I have a binomial. I got to check to see if it's the difference of perfect squares. 25 is, n squared is, 9 is, and it is the difference. So this breaks down to two binomials of 5n minus 3 and 5n plus 3. Don't forget to bring down your greatest common factor. Okay, couple activities. Activity 1. Try to factor 12x to the fourth minus 48x squared, and also factor, make this activity 2, factor 2a to the third minus a squared plus 10a minus 5. Give those a try and bring those to class tomorrow.